Occasionally in geometry you're going to see some problems that involve either a triangle inscribed inside a circle, which means that each of its vertices are points on the circle, or you might see a circle that is inscribed inside a triangle. Okay, you might see this different ways, and you might be asked to find the area of the triangle, you might be asked to find information about the circle or the circle's radius. Just depends on what you're given. Okay, so we're going to say that this is an equilateral triangle. We're going to say the radius of this circle is 8, and it's easy to find the area of the circle since I have the radius. We're going to find the area of the triangle. Okay, and here's the key. The key is drawing the radius to the right location. Okay, I can put this radius anywhere I want to put it. Okay, I'm going to set it up so that the radius of the circle goes to one of the vertices. Okay, that length right there is 8. Okay, if this is an equilateral triangle, then that's a 60-degree angle, and it just got bisected, and that's going to give me a 30 right there. Okay, the other thing I'm going to do is I'm going to drop a perpendicular to one of the sides. Okay, you might remember from geometry, or if you haven't seen this before, if you drop a perpendicular to a chord of a circle from the center of the circle, it's going to bisect that chord. So we've got a right angle here. This length here is going to be equal to that length there. Okay, notice something. This is huge. Equilateral triangles have 60-degree angles, which means they can be broken up into 30, 60, 90 triangles. We've got a little 30, 60, 90 right here. This is 8, this is going to be 4, that's going to make this 4 radical 3, okay? And then that whole length there is going to end up being 8 radical 3, okay? So I've got a triangle with side lengths of 8 radical 3, and then we can find the area. So we could do the side squared over 4 radical 3 formula. You could figure out what the altitude of the whole triangle was and do half the base times the height. Lots of different possibilities here. I'm going to go this route though. 8 radical 3 squared divided by 4 times radical 3. Let's see, that's going to be 64 times 3. Actually, let me do it this way. That's going to be 64 times 3. But we're going to be dividing that by 4. 64 divided by 4 is 16. 16 times 3 is 48, okay? So 48 radical 3 square units would end up being our final area of that triangle, all right? Now, I could do a reverse version of this. I could inscribe the circle inside the triangle, okay? So let's do that. We'll put the circle inside the triangle. So the same kind of thing. Let's say we have an equilateral triangle. We have a circle that's inscribed inside the equilateral triangle, okay? And we'll say that the circle is going to be tangent to the triangle in these 3 places, okay? These should be midpoints of sides if that's an equilateral triangle and we have a circle inscribed inside of it, okay? So let's say that the radius of the circle is, let's say that the radius of the circle is equal to 4, okay? Same kind of thing. You should be able to drop a radius there. You've got a length of 4. You're going to have a length of, this is going to be a 60-degree angle here, so we've got a 30 and a 30. This is going to be an 8. That's going to be a 4 radical 3. You can double that to get 8 radical 3 for the side lengths. Similar kind of thing. You should be able to break things up into triangles. So hopefully those 2 examples give you some ideas of how interactions between triangles and circles can work.